We are not there. No. Let's scroll back up. We're right here. We did do this one, right? Last time we finished that one. Okay, so then I left this one to kind of figure out what's going on. It wants the p-value. Again, we're going to definitely use GeoGebra for all that. But notice that it has like data points. So this is a little different than the other ones. So normally what I do, as you know, I go over here to the statistics, z-test of a mean, I put all the numbers in and we're done. I mean, it's just really that easy. But we can't do that right now because there's a lot of data points. So we have to go somewhere else. In fact, what we need to do is go to the spreadsheet. So clickety click, blah, 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 get to the spreadsheet as we're normally used to. We've done this back a long time ago. Start putting the numbers in. Dun, 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 dun. Hope my music isn't copyrighted. YouTube will take it off. That would be funny. So, like, I haven't even read the problem. That's the thing. I haven't even read it. I just know that I got all this data stuff. The only way to do this is with the spreadsheet. So far, okay? Okay, cool. So, I'm going to go and do the one variable analysis like normal. Like, I'm going to blow it up full screen. One variable analysis. We've done this already a lot of times. And then you click this little sigma x thing on the side, right? Because we've done that 100 times too. So, no big deal there. And you get all your numbers. So let me get my numbers. Where did it all go? Give me my numbers. Where did my numbers go? Okay. I guess I'll have to. There we go. Okay. There. Okay, that'll work for now. So what I could do is write down some of these numbers. Like there's the mean, there's the standard deviation. We can use some of these now in GeoGebra on the other side, right? But there's a tool built in just for this. So hold on, I'm trying to scoot this thing over. If you look up here, you know, statistics. Well, look, z-test of a mean, t-test of a mean. That's like what we're doing right now. It's one of those guys, right? I can't remember which one we're gonna see here in just a second. Hello. So let's see what we got for the z and then for the t. For the z, we have this little sigma thing at the top, but for the t, we don't. See the difference there? Let's do it again. I have this guy at the top, but for t, I don't. So which one would work in our situation? Do we have the sigma? So you're all feeling what I'm feeling there? Once we put in the numbers, it'll be fine. We're done with this problem, but here we go. So the dean of a university estimates, there's a keyword there, claim, that the mean number of classroom hours is not 11. So let's time out, right? Right there, that first sentence, we can already construct everything. H naught, H sub A, we're going to use mu for a mean. We got 11.0, 11.0. But when it says is not, what goes down here in H sub A? Not equal to, different, not equal to, something else, is not. And so the opposite of that, what would go up here? Plain equal to, very good. Yep. What kind of tail test is this guy? Two tail test. And got a little bell curve thingy in case somebody asks. Looks something kind of like that with two little tails on it. So we set it all up. Oh, and again, just a reminder, that's the claim in the bottom, right? It's always the claim in the bottom. But we set it all up. Everything's happy. Cool. That was just one sentence. So here we go. As a member of the student council, you want to test this claim. Okay. Random sample for 8 full-time. There's something. Full-time faculty in a week. Assume the population normally distributed. You got an alpha. Can you support blah, 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 blah. Okay. Did I ever get a standard deviation? I don't see one. I don't see one. I got 8. That's the number of folks, right? That's how many. And look, 1, 2, 3, 4, 5, 6, 7, 8. There it is. So that 8 didn't help me at all. I don't have anything else. So yeah, I'm going to use the t-test because again, I don't have it. What was the mean though? What's the mu that I'm putting in? 11, 11.0. And you can see right here we got 3 options. But we already got the not equal to, right? That was what we were supposed to do. And this should give me all of the answers. We're done. We don't have to do any other math. Yay! So let's fill in whatever they say. P-value. There it is. You see it right there. P. Yep. 315. There's dyslexia coming in again. 3155. Oh, 2 decimals? You know I don't like doing that. I know, and Newton's going to be like so upset with me. Okay, so they're going to say reject, fail to reject. That's all that stuff that we're going to talk about now, of course. Let me get a little bit more room over here. So we got our P and we got our alpha. P was the 3155, and alpha, what was alpha again? Do you remember? The 0.10. Yep, that guy. 0.10. So I'm looking at which one is bigger. Chomp, chomp the bigger one. So which one's bigger? P is bigger. 30 is definitely bigger than 10. So P greater than alpha. What's that decision rule for this? Fail to reject. Fail to reject H naught. Very good. What's the another phrase for this? Accept. Yeah. So we're accepting H naught. We like H naught. H naught's cool. We get along on the weekends. We're happy together. Da, 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 da. So like already I can start putting in some of these answers. Let me scroll this. Sorry, scroll this over some. Yeah, there, a little bit more room now. So it's the same as all the other times. It's just the only difference is where we went to in GeoGebra, but everything else was the same, right? We just go to the same style there. Hello. Okay, so did we reject or fail to reject? Fail to reject, right there. Fail to reject. Yep. But I want to go and do the rest of the problem. I want to like fulfill what we were doing, right? I want to actually accept H naught. Let's accept H naught. Here we go. I like H naught. Check marks, smiley faces. Let's do a flower. Flowers, sunshine. We love H naught. H naught's great. But what does that mean about this guy? Ooh, bad claim. I mean, you can only do one or the other, right? So bad claim. And so I'm going to say yes or no support for the claim. And you're going to say it's no support for that claim. That claim is bad. Bad claim. He said, oh, it's blah, blah, not equal to this. That was wrong. So now let's translate that into A, B, C, or D. Which one would be the right way to finish that off? Like what option looks the best? D? You like D? So yeah, insufficient support. So that's like not support the claim. So I like that. Significance level. Yeah, I think that's it right there. Yeah. Cool. So yeah, no support. No support for the claim. That's what it's trying to say. Notice the key phrases though. We never reject the claim, right? I'm always saying yes or no support for the claim. That's that key word there. You know what I mean? So we reject H naught maybe, but you know, not the claim. Cool. Okay. I know we've done it like a bazillion times. I know. But we'll get through this together. And then chapter 12 is brand new and it's going to be fun. So, all right. Any other questions? Keep cruising. Let's do some more. This one does not have a lot of data. So this one's like a traditional, straightforward one. It even says use the t-test. Oh, thanks, I guess. So we're going to put in our numbers and do it. Look, it's not even a word problem anymore. It's just like, here's your number, put it in. Okay, I guess. So we're going to statistics, of course, and we're going to do t-tests because it says use the t-tests. Okay. They actually have everything kind of set up for us. Just about. Here, let's do part A first, just in case. So you can see this claim part right here, the not equal to. So then which one would be the correct statement? A, because, very good, because the claim is always in the bottom, right? You can also say that the equals is always in the top, right? Always an equals in the top, for sure, 100% of the time. So we couldn't choose C because that's flipped. We need the equals in the top. Awesome. Okay, and then it just says, hey, find all the values. So we're just going to plug them in now. What goes in the mu box? What do I put up way up here? No! What do I put up here? 24. And then not equal to. What's my mean? What would I put there? Yep, the 19.8. You got it. S. Yep, 4.3. Very good. And then N. Do we have an N? 15. Yeah, I'm just like tossing them in. So it says, what's the standardized test statistic? That's that T over there, so negative 3.7829. Okay. It's so fun that I can do that. I can do that. Y'all can't do that, but I can. It's just like that instructor cheat button, you know? Man, you want that, I know. What's the p-value? Well, it's right there. 0.002. Yep. Cool. I mean, they just asked, hey, what's the number? So there you go. And then it's going to talk about all the stuff that we need to do. So let's go and do that. So I have my P. Hello. Haven't seen you in a long time. Thanks. So I got my P and I got my alpha. So 0.002. My alpha, what was my alpha again? 0.01. Thank you. So it looks like there's 2 versus 1, but it's a little different, right? Because there's a 0 there. So chomp the bigger one. Which one's bigger? Alpha's bigger. So I got P is less than or equal to alpha. What do I say here? You got it. You got it. Reject H naught. Yep, definitely. That's that decision right there. And so I want to do that. I want to reject H naught. I want to like look at what it says. What does it mean? So this H naught up here, the one that I said was cool. No, it's not cool. Bad. But if I look right here, then the claim is good. Good claim. Yay. Smiley faces and check marks and all that stuff. Claim good. And so here, let's do some decisions here. I got yes or no support for the claim. What would I say? Yes, support that claim. Claim was good. We like claim. So then I have these options then. You like C? So yeah, reject H naught. That's what we had right there. So that's a good one. Or that one. And not enough evident. Oh, there is enough evidence. Yeah, there is evidence to support. That's saying yes, support. Okay, good. Yep. Like the other one says not. So that would be bad right there. Whew. Have y'all been keeping a tally of how many these have been? What has that been? No? It's like 30 or something of these things, right? Hey, look, we got more. But that's why I said chapter 9. It's big, it's intense, it's a lot of stuff. But in the end, it's very procedural, and we just do the same thing again and again and again every time. Yeah. All right, cool. So moving on to the next section. And it would be really cool if we finish up chapter 9 today. I don't think we would have an issue. Again, there's only 3 questions in this whole section, so like I'm not too worried. The main difference here is that we're doing proportions. So look, we did Z, we did T. Now we got proportion. That was it. That's the only difference here. Everything else is the same, okay? So that's my new place, my new home. And blah, 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 blah. Here we go. A research center claims that less than 30% of cell phone users, blah, blah, connect to the internet, blah, blah. Okay, whatever. Let's start setting it up. H naught, H sub A. Now, this is a small difference, and I'm sure they're going to do this on the homework. They're going to have like a little option there. Are we looking for average for mu, or are we doing p for percentage? P for percentage, or probability, or proportion, or whatever. That's that 30% right there. Okay. When it says less than, what goes right here in H sub A? It says less than, and you put less than. Yeah, exactly. What kind of tail test is this? Left tail test. And if anybody asks, looks kind of like that. We saw that they ask sometimes. So, what goes in the top? Yep, greater than or equal to. Maybe a plain equals, depending on what you're doing. But yep, that's definitely good. Cool. Again, I'm just going to remind you that Newton might want just a plain equal sign. That's not technically correct, but it might. I think we did that once, didn't we? And it said just plain equals. It's fine. We can get over it. I'm going to try to get over it. Maybe during the weekend, but but anyways, yeah, it's just the opposite. Okay, last one. This is the claim, and I think we're all good to go. All that from just a single sentence, the very first sentence. So, in a random sample of 86 adults, 20% say that they use the internet, blah, blah, blah. Do it. So, this is where we start putting stuff in. What do I put in for P? Yeah, the 30%. I'm going to put the 0.30. I think that they want it in decimal form, but we'll find out very quickly if we get weird numbers. Less than. And this is where it kind of gets weird. I can definitely do N. How many folks did I survey? Definitely no problem there. But they're wanting to know a whole number of people who said yes. I can't put 20% here. That it just doesn't work. We have to do something about that. So how it works is that we're going to do the 0.20 times the 86. Or I actually prefer this style, but it's the same thing. 86 times 0.20. I'm trying to tell it 20% of the 86. Now, as soon as I like hover off of that or hit enter, it's just going to go bloop and change the number, right, to the actual whole number of people they asked. But that's what I'm typing into GeoGebra. That's what it looks like. Cool. That's what we're typing. I'm gonna go off and like hit enter. See, bloop, and it changed it. I didn't know that. I didn't really care. I was just making sure that I put it in correctly. And so, cool. So then let's look at what results we got. I got a p-value. Here we go. P-value of 0.0215. Alpha was 0.05. So I got 2% versus 5%. Chomp, chomp the bigger one. Alpha. P is less than or equal to alpha. Therefore, I reject H naught. Yep. Yep. Very good. So, change a different color here. I want to reject H naught. I want to. What does that look like? I want to see it. I want to do it. I want to actually do what I said. So I'm going to reject H naught as rejected. No good. But then what's left over is the claim. Claim is good. That's a good claim. Smile faces. That was a bad smile face. Flowers. Let's do a rainbow. Rainbow. Anyways, so if the question comes up, yes or no, support for the claim, you would say, yes, support that claim. Claim was good. We like the claim. And of course, all that's just the multiple choice stuff that we have to click. But yeah. And we did it. Well, we did it again. Count it, 31. It's okay. We only got 2 more. Only 2 more, and then we're finally done. Hopefully, technically, you're not though. You got another 30 to do on homework. I know, it's great fun. Any questions though? Okay, let's go and do it again. A Roper pole states that 5% of U.S. Americans have vivid dreams about UFOs. Okay, I want to stop here. Now, they can hear you, but they can't see you. Okay, so you can just tell me right now, is any of y'all dreaming about UFOs? You're kind of nervous about the no. Oh, that's funny. Okay. Um, I don't even know what I could say about that. So let's keep moving. If you think that you think the actual percentage is different. Okay, well there we go. See, now we're starting to kind of get somewhere. H naught, H sub A. We're going to use a P because we're talking percentages, proportions, that kind of thing. I'm going to use the decimal form. Is different. What do I put here in HA? Not equal to. Didn't say less, didn't say more. Is it different? So then the opposite of that would be a plain equals. Yep. So this was my claim. What kind of tail test? Two-tailed test. And of course, if they ask, bloop, bloop, bloop. That's the worst one ever, but you get the idea. It looks something kind of like that. Awesome. I guess I should probably read the rest of the problem. So to test this claim, you ask 250 adults if they had vivid dreams about UFOs. Well, we asked, what, 15. So you think it's a good study in here? No? Okay. Right, the magic number is 30. Duh. Well, that's true too, because now I'm putting you all on the spot, you know? And it's all public-like. Oh, you wouldn't tell me otherwise. So anyways, out of those, we got 8% that said yes. So let's put the numbers in over here. What am I going to put in for my P up here at the top? 5% not equal to, I don't know what the successes is, but I could definitely tell you N is 250 folks. So now we got to get the number of successes. What am I going to multiply that 250 by? Yep, 0.08. Not 80, just 8, I guess. Here, yeah. Okay, well, I think that's going to be good enough. Oh, I just clicked off it. But y'all saw it, though, right? You saw what I did? 250 times 0.08. Right? It just happened to be 20. I mean, we could do this on the side, right? We can pull up some Desmos or hand calculator, use your phone, but I just wanted to just type it all in at once. So yeah, there we go. So 20 people out of 250 had said they had vivid dreams about UFOs. And so I have a p-value. I have an alpha. P 0.0295. Alpha was, what was alpha? Oh, there it is. You're right. Most of the time when I ask, I actually know the answer. This time I didn't. So just want to tell you that. Chomp chomp the bigger one. P is greater. So P greater than alpha, therefore I, there you go, failed to reject. And failed to reject, another phrase for that would be, I love that. So yeah, we're accepting H naught. Whatever H naught was, whatever the original was, the status quo, we like it. So I want to do that. I want to accept H naught. I want to say, see what that looks like. So H naught, we like it. Cool. Smiley faces. I can't draw aliens. So do aliens have like big eyes? Maybe no noses. It's like 2 dots. Maybe like a. Can I draw an alien? What do you think? Oh, it's coming together. Yeah. But they're not talking about aliens. They're talking about UFOs. Oh, my bad. It looks like half a Saturn. We're going to do little shiny things on it. Okay, there we go. Reject a claim. Well, you can't say that. I'm so sorry. My bad. Can't say reject. But this claim is bad. It is a bad claim. And so we can not reject it, but we can say yes or no support for the claim. And which one would I say? Yeah, no support for that claim. Bad claim. I know the technical words. I get in trouble if I said the word reject. That's like a meow. The other teachers get on me about that sort of thing. No support for the claim. I don't even know what they're talking about. What are they talking about? It's different than 5%. They're like, no, it is 5%. This is the last one, guys. This is the last one. Aren't you so super excited? We've come so far. Medical researcher says that there are more than 21% of adults who are smokers. Blah, 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 blah. Here we go. So let's start setting it up. H naught, H sub A. We're talking proportions. We go to P, 0.21. More than 21%. What do I put down here in H sub A? Greater than. And so up top it's a sweet. Thank you. What kind of tail test is this? Right tail test. And it looks something like that. Again, all of that, setting it up from one sentence. I don't know if I should go faster or slower in the last one. In a random sample of 160 adults, 22.5 say they're smokers, and then the alpha, and there we go. So they're talking rejection region. I will actually answer this to what they're wanting, but every time what we do is the p-value. So let's go through and put it in. So up here, we're going to put the 21 less than, greater than. And my n was 160, but what am I typing in the successes? Yeah, exactly, 225, yeah. 160 times the 225. I'm just making sure you all see it, because I'm going to hit off of it, and it's going to give me a whole number, you know what I mean? Are y'all good with what I'm doing? Okay. I'm going to stop now. Here we go. I'm going to stop now. Here we go. I'm going to click off of it. Here we go. Here we go. There we go. So that was 36, basically. 36 people are smokers out of the 160. Okay. So then we got a P. We got an alpha. My P was 3207. My alpha was 0.03. Wow. Chomp, chomp, the bigger one. So P greater than alpha. Fail to reject. Yep. Fail to reject H naught. Except, very good. You already know what I'm going to ask. I know, going through it 30-something times, I guess you kind of just get the hang of it. I can't even spell accept. It'll work. Accept H naught. So let's do that. I'm going to accept H naught. I like H naught. Happy times there. But then the claim is bad. Bad claim. Bad. So we got yes, no, support for the claim. No support for that claim. Claim was bad. And I didn't even answer the other questions. So I actually have to answer the questions now, but at least we got, the final conclusion, I guess you can say. So let's do the rejection region stuff. This is a nice little review. Again, I wouldn't say this is required all the time. We did it only like a couple times, but here we go. When I'm looking at that left tail test, or I'm sorry, right tail test. Okay, let's try that over again. When I'm looking at the right tail test, oh, get it. Okay, it's close enough. We're looking at the area over here. And this area is the alpha, is the 3%. 3%. So they're saying this is 3% over here in this rejection region. I'm going to call it rejection region. Okay. What they're curious about is, where's the cutoff line? Where's it, the cutoff line between the, the badlands, the sticks, and all the trees that, the trees go real. So that's pretty bad, right? We don't want that. Versus on the other side is like the sunshiny side, and everything's happy. So, where's that cutoff line between the two? Well, it's not here. We actually have to go to the pictures, you know what I mean, and draw it out on the bell curve stuff, right? Which, happily enough, is right there. So it's like you just click on the distribution rather than statistics. So I want to have this picture. I want to create this picture here. And so we have it on this side. And I'm going to say there's 3%. Do my two pictures look, well, at least close enough? Close enough for Chad's work, you know what I mean? And so the cutoff line here was 1.88. Okay, so that's their cutoff line for that one. Good so far with that? Okay. Again, we already had answered the question. I mean, we already finished this problem. It's just that they're wanting more out of us. So we had, and this is this standard test statistic. We're just kind of using it up here. We got 0.465, which is somewhere like right on here, I guess. 0.4658. Like, again, just as a neutral color here, this right here is 0. So it's somewhere in between those two. I'm going to ask, did we fall into the rejection region? No. So therefore, fail to reject, because we're not in the rejection region. There you go. Wow, Chad, couldn't we have done that with the p-value? Yes. Shouldn't we be using the p-value instead? Yes. Why are they asking for this other stuff? I don't know. Just trying to fill your time up. But there you go. We did it. Cool? Okay. Was it 33? A whole bunch. We can go back and count one day. That was a whole bunch. Are we good with this chapter 9 stuff? You're yawning on me. So we have some time left, and I would love to do the chapter 12 stuff a little bit. This is really fun and exciting stuff, brand new, completely different than everything we've been doing, but still using GeoGebra, of course, okay? So this is fun. This is new. Here we go. Yeah, I know. That was so exciting. Okay, good. Good enthusiasm. So brand new stuff. Correlations, scatter plots, and stuff like that. I want to just, like, this is all great, but I really want to just show you the pictures, okay? What we're going to talk about is correlation. Now, one thing, before we get started on the whole chapter, correlation is not causality. Causality, I don't know how to spell it, but you get the thing. So the most perfect example, everyone knows about this, okay? Well, you know, there's a correlation between smoking and lung cancer, right? They always say that kind of stuff. Makes you scared. But it's a correlation. Does some people who smoke always get lung cancer? No. You said yes. Yes. So, I mean, sometimes there's, huh? Yeah, well, okay. We all eventually die, but I mean, that's kind of gruesome. Not for a YouTube video there, but anyways, the bigger point though, the bigger point is that there's a correlation, and yes, we see it, but that doesn't mean it's necessarily going to happen. We don't really know that it will happen or not. But we can look at the correlation and see, you know, positive or negative in one way or another. So let's start with the positive. That's actually the easier one to do. So positive means the more of this, then the more of that. So more of, let's do something less bad than that stuff. Let's do another correlation, okay? I know. More waffles, more syrup. Is that, yeah? Okay. The more waffles you got on your plate, the more syrup you're going to need for them. There it is. That's a positive correlation. But hold up, not everyone likes syrup. Some people. Is that weird? It fills in all the little holes, But the syrup absorbs it, bro. That sounds so good, but anyways, so the more of this, the more of that. Yeah, generally speaking, that's what a positive linear correlation would be. Okay, and so let's do a different one. Let's do the negative. Again, correlation, not causality. So negative means we're going down. The more of this, the less of that. What would be? Oh, I know. I got one. The more waffles, yeah, the less pickles. Yeah, see, there it is. So, like, you know what? You got a big stack of waffles. And you know what would go really good with all these waffles? Pickles. No? And that's the point, right? That's the point. So the more waffles, the less pickles, or the more pickles, the less waffles, kind of thing, right? They're not, you know, some people could probably do it, but the correlation is that there's less of this, more of that kind of stuff. Make sense? All right, cool, awesome. Okay, so that would be the negative, which is opposed to no correlation. So here's weird. The more waffles, and then I'm going to say question mark, question mark, question mark, elephants. Say what? Okay. So you show up at a place. Let's just say it's the zoo, and you're like, man, I want some waffles while I look at elephants. Not you're like shrug, like, and that's the thing. It's not like you're like, oh no, elephants and waffles do not go together, because it just doesn't make sense. But you're also saying they're not like, oh yeah, I'm feeling the waffles with the elephants. They're completely unrelated. There's no correlation there, and that's why this is not negative or positive. It's just all over the place. You know what I mean? It just makes no sense. You can't relate them. And so nonlinear is the weird one. Okay. So this would like change over time. I'm trying to go with waffle themes here. Okay. Oh, that's good. That's a great one. So yeah, the more waffles, the later in the day, right? So, well, it would be like in the middle of the day. So let's just say this is like the morning time, right? So let's just say this is around the 9 a.m. To 12 noon, about. So then over here at 6 p.m., you're not really wanting the waffles. Okay, some of y'all, I get it. And then here, what would this be? 6 a.m. No, that would probably be more like 2 a.m. maybe. You're like, yeah, I'm feeling some waffles at 2 a.m. Yeah. IHOP is always open. But the bigger point is that, yeah, it's the time of day. More waffles here, less waffles there. Okay, cool. Okay, cool. I like that. That was a great one. I like it. Okay. So correlation. And there's your formula. What? Did you already turn the page and you saw it? No. Okay. But you don't look surprised. Because you know me. You know me. It's going to go to GeoGebra, won't it? Like, we ain't doing none of that. So yeah, this means really nothing to us. I'm very happy to see it, but yeah, we're going to use GeoGebra every time. I'm going to keep moving. So going back with the correlation stuff, they have this thing called the R value, and it's telling you what kind of correlation we have. And R values can go between, I'm going to write this up at the top, -1 all the way to +1. So -1 to +1. -1 means strong negative correlation, and a +1 means strong positive correlation. Let me write that back up here. -1 to +1. So -1 is strong. I can't spell strong. No. Strong negative correlation, while a +1 is strong positive correlation. Can't spell positive, apparently. Okay. What I like to think of this as is a percentage. It makes it way easier. So instead of saying -1, I like to think -100%. Now it's not technically that, but it's rough and it'll work. And I've gotten a lot of people to pass my class using this. So there you go. So don't tell the other teachers, but this is fine. So I'm thinking -100%, +100% correlation. Okay. So I'm going to ask a question here. What is the cutoff line between strong correlation and not strong? Like if you said that's a good percentage, that's a good score, what would that cutoff line be? Say on an exam, where would that be? 80? That's pretty good. What's another one? 70, bro. I wanted to pass. See you later. So like 60, 70, 80 would be about it. What if you got a percentage that was 20% something? That's pretty weak, isn't it? It's not a lot going on. What if you got 90? Oh yeah. So where's that strict cutoff line? I don't have one. I don't have one. You were looking for one. I don't got one, bro. But I'm going to say around the 70 mark is where it starts becoming, I would say, like weak versus strong. Okay, weak versus strong is kind of like the cutoff line. Okie dokie. And this kind of makes sense in our brains too. What would you get on an exam? 70 is like, eh. So here we go. And it says R equals 1. That means R equals positive 100%. And look, positive 100% is every duck is in a row. I mean, it's a 100% straight line. And they're using tickets and costs. The more tickets, the more costs. 100%. It's always going to happen. Strong positive. Look, we got 81% positive. Height and shoe size. That makes sense, right? Right. The taller you are, probably the bigger your shoe is, because you got bigger feet. Because you're probably just bigger. Okay, just wanted to say that. Okay. Anyways, weak. You can see I got a positive 45% basically. And I would say that's weak now, right? It's past that 70 mark. If you got a 45% on a test, that would be sad, right? That would not be good. We don't want that. So income versus amount spent. So some people don't spend all their income; they save it. Go figure. And some people spend more than what they make. Oh. So, but generally though, yeah. And so the negatives, negative 100%. You can see it's like a straight line again. Number incorrect in exam score. Okay, we're not going to focus on that. So we're not talking about that one. No way. Negative. So I got negative 92%. Absences and test grade. Oh man, don't talk about that in this class. No. Just playing, bro. We're fine. You had places to go and things to do. And then finally, you can see that this is literally a 4%. 4%. Like positive, negative, doesn't really matter. That's so weak. And so they're going to say it's just no correlation at all. IQ score versus how tall you are. Just no relation. Just you can't tell. Okay. So here's an interesting thing. Did you see me draw a line right quick? Those lines right there? Did you know? Did you know that you humans are really good at doing that? I mean, would you be drawing the same lines that I drew? Uh-oh. Right? Couldn't you humans like draw a line, best fit line, kind of like going where it's going? Are you good at that? You're very good at that. You're a human. You can do that. So humans, very good at drawing lines. Can you draw a line for this guy? Straight line? No. And that's the point. No correlation. Makes sense. Now, here's the other thing good about humans. We could draw that line, but computers can't do that very well. I mean, at this point, we had to program them to do it, and they had to use this huge formula. But, like, we can do it without a formula. So, yeah, that's the cool thing about being a human. All right. So, y'all are going to help me. We're going through these questions. It says the scatter plot, competitive chess player ratings and their IQ, blah, 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 blah. What would you say is going on here? A, B, C, D, or E? Say it again. What is it? B. Positive, because it's going up, right? And it has this with deviations. What does that mean? Yeah, we got like these two guys floating around there. These are called outliers. But we already have talked about outliers before. That's what I would say. Cool. Good. That's an easy one. I like that. Awesome. Okay. What about this guy? Which one would be the best choice for this? Yeah, perfect means like 100%. You know what I mean? Negative because it's going down. It's going down. So that's negative. There you go. Cool. Yeah, perfect is 100% down. Easy enough, right? Just copy paste these kind of things. We got this. They got more of this? Yeah, I love it. Whoa. Here we go. There is a lot of dots. But if you look, it's kind of interesting. So they have age on the bottom here. So that's age. And then here they don't tell you. They say it's in the thousands. It's a thing. And we're supposed to pick what makes sense for that thousands, I guess you can say. So going through, we're going to see which one makes the most sense. So we got age versus body temperature. Again, this is in the thousands. So does this range here look like body temperature? You're not at 26, you're not 40,000 degrees, but then by the time you get to 34, you're like a few hundred degrees. That doesn't make sense, does it? So that's not cool. Okay, age versus balance on student loans. You like that? So yeah, at 24, you probably got a lot of student loans, but by the time you're in the late 30s, you're probably down to zero. And then you can see there's some people that are early here and they still got none. So that one looks pretty good. So yeah, age and income. So at 24, you're making $40,000 a year. It's not too bad, right? But then by 30s, you're now making zero. And then what does it keep going down? No. So yeah, I don't think that works there. And then height. Are you 40,000 millimeters tall? It's got to be millimeters, right? But by the time you're 30, you're just definitely you're falling apart that much. No way. You see what I'm getting at there? So we just kind of interpret what that would mean from the picture. Can you click multiple choice on your homework? All right, that's the bigger point here. Awesome. So I don't know what they're wanting to do here, and we can do that. We're going to do that right here for this guy. So let's go and find the correlation coefficient on GeoGebra. So as you see, we have numbers, and we got to put those numbers in. And so I'm going to go to Classic, and I'm going to go to Spreadsheet, and they got two sets of numbers. So I'm going to put them in. Whoa, 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 whoa. 1, 2, 3, 4, 5, 6. 400. Da 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 da. Yeah. Okay, awesome. So I had to put them in the right way, of course, going down, not across, but we've done this all before. We've had two columns before. But this is finally going to be different than what we've done before. This is going to be the new part. I know you're totally ready for this. Here we go. I'm going to highlight both columns. And instead of doing the one variable analysis, I'm now going to do two variable regression. And if you look, it even has like a little scatter plot with a line through it. That's what we're doing, right? That's our chapter 12 stuff. So that's the first time we're clicking there. So definitely click there. That's the first time we're clicking there. We're definitely clicking there. I'm just making sure 100%. Okay. That way, if you're 2 times speeding my videos, at least now you saw it for a second. There we go. Click it. And it gives us a scatter plot. And immediately, I could probably get this answer here. I'm looking for which one of these 4 looks like this. And so which one, A, B, C, or D? Yeah, I think A looks the best. And you can notice there's a few things here. Age is on the bottom as your X values. And that's what we have down here, right? You can see the 1, 2, 3, 4, 5, 6. This is always going to 7. 7. Make sense so far? And then, yeah, have y'all ever, I know this is kind of weird, especially in this kind of day and age, at night, have you ever looked up? Whoa, what's up there? Stars. And so I often think of it kind of like you're looking at star patterns. And so you're looking at what star patterns. And so for me, I'm looking at this and it's got 3 bumps and a line. 3 bumps in a line. So I'm looking for 3 bumps in a line. Okay? I know that y'all are all really good at this. Y'all are humans. You're super good at patterns, but I'm just making sure. Okay, cool. Now it says find R, and this is the thing that I don't have yet. I need to go and find the math. So down at the bottom it says regression model, and we're going to click on linear every single time. R is for the linear correlation coefficient. Oh, look, they even drew a line for me. How nice. So far, so good. Do you notice there's an equation down here? We're going to use that in another section here in chapter 12. So this is very useful, just not yet. We can even click down here and start putting in numbers. Actually, there'll be like 3 or something. And they'll start giving you values. Again, very helpful, but not yet. We're not doing that yet. What we need is the R. So this guy, there we go. So there's your sigma x, just like the other times. And it comes up with all your numbers. And there's your R right there. 962. So I want you to conclude for me. This is a positive. This is 0.9, or yeah, 0.962. Would you call this strong or weak? Strong, 90-something percent, right? Is it positive or negative? Positive. But you can probably see that just by looking here. It's going up. Cool. So there's a strong correlation between age and vocabulary size. See you later. Thank you. Cool. Good to go? Pretty straightforward, I think. And yeah, 96%. Oh, turn the page. Strong positive. There we go. Well, I was anticipating it. Okay. Good? Straightforward. We're going to do this a whole bunch more times, though. Oh, no. I hate this one. Now, okay. I do want to pull up the homework eventually, just not today. This is on your homework, and it's the most annoying problem in the world. Okay, so they're going to give you a whole big list of points. They don't show it right here. They're going to give you the actual points. Okie dokie. They'll say like 15, 20.2. They'll give you the 55.64. Okay, so all those. They'll give it to you on a big list. You have to take all these little dots that are all scattered over the place, and you're going to click and drag them around to where they need to be. Not too bad, except that when your hands are shaking, you're trying to get it to the right place. And that really is annoying. One other time that I got this one wrong, notice it has state 1, 2, 3, 4, and 5. I had mixed up my points where I clicked on 5 and moved it where the 3 should have been. Oh no. Oh no. It's all wrong. Oh man, it was so annoying. So I'll show you that later, not today. But after you go through that antagonizing, I'm gonna roll with that. The antagonizing thing from Newton, trying to rile you up. Then it just says, okay, find R. Okay, and which is easy at this point because we can just put in our numbers and we're done. So let's do that. So I want to put in all my X's, and then I want to put on all my Y's. So I'm going to start with the state 1. So I got 15, 35, 50, 55, and then 60. Like this is what it looks more like on Newton, is like a list that they give you. And then that's when you start moving things around. 20.2, 30, 45, 64, 70. Good? Okay. Highlight. Click here. 2 variable regression. That's all chapter 12 is right here. This is chapter 12. Click. And we're going to use this down here. It pretty much stays in linear mode. As long as you did it once, it'll kind of stay there. But we still need all the other things. So sigma x, and it gives you all of the numbers that you need. So I'm going to write it down. R is equal to 0.9425. There you go. So 94, positive 94% correlation. I'm going to ask the same questions as last time. Is that strong or is that weak? Strong. Is that positive or is that negative? Positive. Strong positive correlation. Okay. So far, so good? I did not answer the question, though. I have to go and read that. Ugh, so here we go. Use the linear relationship graph to estimate the percentage of freshmen that are stay in blah 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 for 45%. 45% public colleges. So you can see public colleges right there, and 45 would be right here. So there you go. Okay. So I went up and I went over, and I found that if I'm going with 45 right here, this is the 45, that my result would be what? Just take a good guess. How much? 48. Yep, I like it. 48. That's your answer. That's what they want. Wow, Chad, did I have to do anything here in GeoGebra? Yeah, maybe. Now I'm going to show you. What if down here I actually put in the 45? No, I wanted to hit 45 and put it in. Come on now. There we go. Look what's the answer. Oh, we got it. We got it. Oh, exactly, right? Just in case they ask. And so that's what their little useful stuff down here. You can just put in a number and it'll give you the answer. Cool? Okay, not every time. We don't have to do it every time, but, you know, and y'all are like, Chad, you know, you normally let us go about now. The calculus class just walked out, okay? So we got to keep going because we got a review next week. So yet another one. Any questions so far? Is this okay? Is it not too bad? Is it better than chapter 9? You have a fondness for chapter 9 now. That's what it is. Yeah, this is a pretty cool. Oh, whoa. Do you see what I did wrong already? Look. Do you see it? Ooh, it's so mean. Yeah, that was mean, man. They don't like me. Anyways, they're wanting hours spent watching TV versus their test scores. Ooh, this will be interesting. I'm not going to look. I'm just looking at my screen and my keyboard, okay? Do y'all watch the TV? How many hours do you watch TV? You're like, I don't watch TV. I watch YouTube. So let's see then what that would do to your test grade. I'm not looking at you, bro. It's okay. Two variable regression, sigma x. I don't know. What do you think, guys? It's looking bad. It's looking down. And so which one, A, B, C, or D? B? You like B? I think you're right. Yeah, the score is your X value. No. Wait, that's wrong. Look around. Oh, man, it's a good thing we're talking about this. Where's my eraser? Yeah, hours is my X value. See that? Huh? Oh. Okay, good. So some other things though. Notice that we have 1, 2, 3, 4, 5 in the bottom. 1, 2, 3, 4, 5, 6, right? And star patterns, right? I got the little dipper, and I got this dude outlier. Got my little dipper. Star patterns, right? Okay. So there we go. I'm gonna pick C. Now correlation R is equal to negative 8154. Oh, that's what you were looking at. Now that makes sense. So then A, B, C, or D? B, strong negative. That's an 81% correlation of more of this, less of that. So more television, less test scores. Now I'm looking at you guys. You're like, I don't watch TV. I read books, right? That's cool too. I like that. You know, it's mind stimulating. Oh, there was other options. Well, we didn't need them. So what does this mean for Is that part of the same question? Oh, okay. Let's full screen it for a second. So what does this mean for the population coefficient, blah, blah, blah? So that's actually a row. That's a row character. It's a Greek letter for R. It goes That's how you pronounce it. But it's row. Like row, row, row your boat. I should probably put the Latinized soundings thing. It's like row, row, row your boat gently downstream. Okay, we're done. So, anyways, in other words, what's going on here? That's a huge table of confusion, let me tell you. And honestly, I don't think we really need this in the end, but I'm going to show you. We're going to move on from this here in a second. I have 1, 2, 3, 4, 5, 6 different folks that I asked. Okay. So in a way here, let me go back down. I got n is equal to 6. Now, normally, degrees of freedom, do you remember how we did that? What do we do to get degrees of freedom? -1, right? N minus 1. Nope, not here. What? It's N minus 2. Why, Chad? IDK. I really don't know, and I'm sorry as your professor. I'm just going to leave that, let that one go. So yeah, I'm going to be frowny face about it, but whatever. So then if we're going to follow the formula, 6 minus 2 is 4. And so we're talking like this one right here, okay? And this number that's associated with it, it's kind of like the line in the sand. It's the cutoff line. It's determining if it's strong or weak. And notice, like, generally, I would say, like, for these little studies here, we're saying it's around 80 to 60, right? Isn't that the zone right here, 80 to 60? We would say sometimes, oh, well, 70 is good enough, or I really wanted an A, so 85 would be not good. You get the point, though, okay? So that's the cutoff line. So I have my 811, and mine was, what was mine? 8 what? I have to scroll back up. 8154. So this was the cutoff line. If you're like looking number line wise, there's 0. Here's my 811. And so mine was just barely on the other side, right? Right here, 8154. So I would say this is strong. I mean, it's always bigger, so it's strong correlation. Significant, I would say the key word here, they use the word significant. So I'm going to say it is significant. It's that whole, like, is it strong or not? Because if it's weak, I don't really care, right? Weak correlation, not a big deal. But strong, ooh, that's that waffles and pickles, right? Like, when I'm wanting my waffles, I sure ain't wanting my pickles, right? So there's a strong correlation there. Is significant. I don't know what else to say there. That's just what they're wanting to go with, okay? Is that cool? We already knew it was strong, but I just want to make sure, verify all that stuff. We got time? I want to come back to this one because it has this guy again. We can like cover it again, double check ourselves and stuff. Oh, and then we'd be done. So, you know what? I want to do it now then. Is that okay? Can I finish it up? One last question. We're still ahead of time. So let me put it all in. They even give you R already. So that's nice. Actually, I think we don't even have to put it in. Look, we have our R already. We're already done with that. Like, look, put it all in. There we go. We got it. Yay. Okay, so what would be my N? How many do I have total? Well, I will get 8 eventually. Yeah, 10. But then my degrees of freedom, I'm supposed to subtract what now? 2. 10 minus 2 is, like you said, I'm rewriting it. It's 8, yeah. Very good. So 8 is what we're looking for here. And this is the cutoff line. So if it's more than 60, we're good, right? That's kind of like the curve on the test. Made more than 60, we passed. We're good. Made a significant score, blah, blah, blah. What did I make? 32. That ain't no good. I didn't even reach that minimum. Now, I can already see that this is a weak correlation already, but like I've just verified it, right? So I would say not significant. It's too weak to say that there's something going on here. Okay. However you answer the question, there you go. Not significant. Is there significance? Is there a significant? You would say no. There you go. Cool? Okay, then we're done with this section. I feel proud of all of us. We got through with it. Thank you, guys. Yes, clapping. Okay.